Hello friends, this is going to be one of multiple videos I will make about Tocharians. These samples are from this study, which you can see on the screen right now. What is interesting about Tocharians and these people in general is that they are an Indo-European group of people who lived in Xinjiang. I'm not sure how to pronounce that, I'm not Chinese, but they lived in this region of Western China, and they were not Iranic people, they were Indo-Europeans, but not Iranic people, which is very interesting because they are kind of an extinct group of humans who their language they were speaking, is no longer spoken anywhere in on the earth. They are they were described by ancient Chinese sources as being blonde and blue-eyed. You can see some depictions of them, the way Chinese people would depict them. It's very interesting. Kind of ugly in my opinion. I don't think they were really looking this way. So they would depict a Chinese person on the right and Tocharian on the left. And there is this whole idea online that they were some blonde and blue-eyed people. You see pictures like this when you look up Tocharian. You see a bunch of pictures that are clearly um, a little bit biased. Pictures that are based on these preconceived notions that are based on Chinese depictions of Tocharians, and we already know how Chinese used to depict everybody who's not Chinese as blonde and blue-eyed. That's kind of how it is. If there is any presence of blonde hair or blue eyes in a group, Chinese people would depict that whole group as blonde and blue-eyed. You know how it is. So I don't really think that Tocharians as a whole were very light. And we're gonna go ahead and explore some Tocharians, their DNA. I already have two samples that I analyzed. Both of them have brown hair, brown eyes. So it looks like the samples I have from Tocharians are not light colored. I will keep looking through these samples until I find somebody who does have blonde hair and blue eyes. But let's go ahead and explore this Tocharian individual. I named her Tocharian too. I'm not really sure what to make of this sample name. So to make it more easy for me to remember, I named it Tocharian too. It is a female. It does not have a Y DNA. There is also another Tocharian individual which you will see a video on later. It is a male, so he does have Y DNA. Let's go ahead and start with her ethnic calculator results with my trait predictor. So with my trait predictor, she is closest to Lutsk, Ukrainian, medieval Ukrainian from Lutsk, Izyaslav and Gvarivich, followed by that is British, followed by that is French, followed by that is corded ware. So it looks like she is pretty typical um, Northern European. And unfortunately, it's not going to be very precise. GED match is going to be very precise. So with my trait predictor, the most precise kind of prediction we can get is that she's vaguely Northern European. Let's go ahead and check what she scores with PanDNA LK10. Okay, so with PanDNA LK10, we get a better picture. And we see that she's actually very different from Europeans. How is she different from Europeans? She's got 41% CHG admixture, or basically West Asian admixture. This is very high for somebody from Europe. Pretty much nobody in Europe has this kind of CHG admixture. Um, she also has 8.37% ASI, which is kind of South Asian admixture. Nobody in Europe has this much South Asian admixture. Once again, it's really atypical for a European. She does not have any ENF. ENF is kind of this Middle Eastern component or Western Mediterranean or like extremely Western Mediterranean component that's present in Europeans, and even Northeast Europeans have about 15% of this component. She does not have any. So she does really not have any Mediterranean like admixture. Um, and she's very Caucasus, and she lacks any kind of Mediterranean admixture. Let's see the oracle, what kind of populations she resembles with this kind of a um, genome. It looks like she has not a lot of European hunter-gatherer admixture either. So there's only 32% European hunter-gatherer admixture here, which is less than what's typical for um, Northern or even Western Europeans. Even like Spanish people have more Western hunter-gatherer. Or I mean, it's labeled at WHG, but it's really European hunter-gatherer. It's really a WHG plus Eastern hunter-gatherer. So even Spanish people score less than her in terms of the European hunter-gatherer components. And with the Oracle, she's closest to Chuvash, Mordvins. I wonder why Chuvash. Is it because of the high? Yeah, it's because of the Beringian and the Siberian. Well, actually, yeah, and Amerindian, yeah. So that makes sense because of the East Eurasian components. She's scoring closest to Chuvash. I guess that makes sense. Followed by that is Mardvin, Pashtun, Russian, Chechen, Lezgin, Kalash, Nagai, and she's actually getting modeled as a mixture of Mardvin plus Kalash or Russian plus Kalash. Kalash are a group of people in Pakistan, so a mixture of, I think they are Dardik people in Pakistan. So a mixture of Russian plus this obscure group from Pakistan. All right. Now let's go ahead and check what she scores with Eurogene's K13. As you can see with Eurogene's K13, this is also a very I would say, un-European score. You will not find many European ethnicities scoring this way. Why? Because she's not scoring any West Mediterranean. That's number one. Not scoring any West Mediterranean is really, it's really rare for Europeans. Europeans tend to score some from this component. She's not scoring anything from East Mediterranean, or it's actually no Mediterranean components at all. The only thing she's scoring is 20% West Asian, which is also very, very high for Europeans. Even Greeks don't score this much West Asian. Even Cypriots don't score this much West Asian. And it looks like if you change the West Asian, if you split it into West Mediterranean and a little bit of Baltic and a little bit of East Mediterranean, then it would be kind of a typical score for a Eastern European, but still not really because of the high South Asian and Siberian and Amerindian. So it's just kind of I'm not sure what this result resembles. I would say it kind of resembles what you would get if you mixed Afanasyevo culture with West Siberian hunter-gatherers. That's what it looks like to me. A mixture of Afanasyevo and West Siberian hunter-gatherers would probably score something like this. Probably, yeah. Yeah, I think it sounds right. Afanasyevo plus West Siberian hunter-gatherers. Uh-huh. Or like Yamne plus West Siberian hunter-gatherers because of the high West Asian and the lack of West Mediterranean and the presence of North Atlantic as well. Because like if you take some other steppe groups such as West Siberian hunter-gatherers themselves, they wouldn't score any North Atlantic. So it does look like a mixture of Proto-Indo-European plus West Siberian hunter-gatherer. I think that's what it is. And with the Oracle, we're gonna see it's closest to Tatars, Erzya, Chuvash, Russians from Kargopol, Ukrainians from Belgorod, Southwest Russians, but closest to Tatars and Erzya. And actually, she's getting more as a mixture of Erzya plus Kalash and Kargopol Russian plus Kalash. Once again, a mixture of Northeast European plus Pakistani is what it looks like. Surprising that she has so many Iranic affinities without being Iranic. It's kind of interesting. All right, now let's see what kind of phenotype she has, what she looks like. We're going to start with noshacot. So it looks like she's got, once again, and this is not, I already looked at two samples from this time period from Xinjiang, two Tocharian samples, and they both have brown eyes and black hair. So, this whole idea that all Tocharians were blonde and blue eyed, it's already kind of falling apart in my worldview. So I'm expecting most of them to have the same phenotype, but let's explore her phenotype. It looks like she's got brown eyes, or brown or darkest brown, right? It's a split between brown and darkest brown eyes. It looks like she's got definitely dark eye color. For hair color, it looks like she's got black hair, definitely black hair, not any other hair color besides black. For skin color, it looks like she's got light brown skin, and probably not other skin colors besides that. Probably light brown skin indeed. For hair texture, it looks like she's got curly hair, which is not typical for East Asians. You will not find that many East Asians with curly hair. Maybe in Southeast Asia. Yeah, maybe in Southeast Asia, but not in China. For coloring related variants, it looks like she's got, okay, it looks like does not have blue haplotype 3, no blue haplotype 2, no blue haplotype 1. Although I say she doesn't have blue haplotype 1, but she actually does. Yeah, she does have blue haplotype 1, okay. But she does also have heterozygous genotype in BEH4, which is very interesting. BEH4 is a very super rare blue eye mutation that occurred somewhere in the Mediterranean, because I'm pretty sure it's occurred somewhere in the Mediterranean, because nowadays it's most commonly found in the Mediterranean. There were Yamnayans with this mutation. When I was doing videos on Yamnayans, I'm pretty sure I did every single Yamnayan that exists, and I've seen like 4 or 5 people with blue eye haplotype 4 among the Yamnayans. So my guess is that she got this mutation from Proto-Indo-European admixture. I don't know. Maybe there was blue eye haplotype 4 among the West Siberian hunter-gatherers as well. I'm not sure. I don't really know that for sure. because it's a very ancient mutation. It looks like she has this genotype in SLC 24A5, which leads to light skin. So West Eurasian light skin mutation. She does have that for SC, but looks like she has zero light color variants here. So that leads to darker skin tone. Actually, she does not have any derived variants for light pigmentation in SLC 45A2. So darker color of hair, eyes, and skin. Um, she does not have the blonde mutation in Ketal G that leads to light pigmentation of hair. It's not a very significant mutation, but people make a lot of fuss about it. You know, she doesn't have it. She has heterozygous genotype here, which actually by Eurasian standards tends to lead to slightly darker skin tone, but like by African standards, it would lead to lighter skin tone. For Eurasians, it's typical to have two light color variants here, and she has one. For sub-Saharan Africans, it's typical to have zero light color variants here, and she has one. That's kind of how it is. She's in terms of skin color, she's somewhere between typical Eurasian and typical sub-Saharan African. Um, okay, we're gonna skip that. Tier 1, nothing interesting here. And for MC1R, there is something interesting here. She actually has one derived variant in this variation of MC1R, which leads to red hair. Of course, she's very dark, so she's not gonna have red hair. You need there's other requirements that need to happen, that need to be fulfilled in order for you to have red hair. Besides having MC1R, but she does have this variant that leads to red hair, which is very interesting, kind of surprising. All right, now let's go ahead and check her polygenic risk scores and monogenic traits. Right. So for the polygenic risk scores, it looks like she's got a above average score for schizophrenia. It looks like she's got a below average score for slightly below average score for type 2 diabetes, a slightly above average score for Alzheimer's, a below average score for multiple sclerosis, 2 risk variants for breast cancer out of 24, which is pretty typical. 10 risk variants for testicular cancer out of 16, which is really atypical. It's really rare. So we're gonna discuss the testicular cancer risk a little bit more in depth later. 6 risk variants for celiac disease out of 8, which is kind of really unusual. So we're gonna discuss that a bit later. 0 for GSS out of 18, which is good. Hold on. 7 risk variants for Crohn's out of 24, which is kind of unusual once again. So we're going to discuss Crohn's, we're going to discuss celiac disease, and we're going to discuss the testicular cancer. Let's keep those in mind. Crohn's, celiac, testicular cancer. For Riefenstein's, 1 risk variant out of 24. I think this 1 risk variant might be caused by genotyping errors because it's just such a rare condition. All right. And for Parkinson's disease risk section, looks like she's got 5 risk variants out of 42. And that's kind of, I can't really fact check that, but 5 risk variants out of 42 is kind of uncommon as well. So it's a little bit high. So we're gonna keep in mind what can we really check here. We can check testicular cancer, we can check celiac disease, and we can check Crohn's. All right. It looks like she's got AA genotype in Comts-Valmet variation, meaning Warrior genotype, MET. Basically lower activity of the COMT enzyme. COMT enzyme is the enzyme that breaks down dopamine in your brain, and having lower activity of this enzyme means there is more dopamine buildup, increased dopamine levels, therefore advantages in attention, tasks, and motivation. She has got TG in this variation of MAOA, which leads to intermediate activity of the MAOA enzyme. MAOA enzyme is also the enzyme that breaks down dopamine, kind of like COMT. Altogether, she's probably more warrior overall, warrior than warrior, because heterozygous genotype in MAOA and warrior genotype in COMT. She does not have any no-go learner variants in the ERD2's pro-phenetine pro variation. Okay, so she's got a little bit higher, slightly higher number of dopamine D2 receptor sites in the brain, and she's got a G genotype in TAC1 of the ERD2. So she has the A allele in TAC1, which is very interesting. And this A allele leads to a slightly decreased number. I say slightly, but it's really not slightly. It's like 20%. A significantly decreased number of dopamine D2 receptor sites in the brain, and a slightly increased likelihood of stuff like alcoholism, Parkinson's, and ADHD. It looks like she's got short form 5-HTTLPR. Wow. I'm pretty sure everybody I'm looking at, like, it's super uncommon to find samples with long form 5-HTTLPR. That's interesting. So she's got short form 5-HTTLPR once again, so she does have a slight increase, a slightly above average risk for depression. I would say instead of having a decrease increase, it's more appropriate to say she does not have a decrease in the risk of depression, because long form 5-HTTLPR comes together with a decrease in the risk of depression, which is not the case with her. Um, we're gonna skip autism. We're gonna skip DDC. For lactose persistence, she does not carry any variants for European lactose persistence. So if she took an ancestry test, they would say, hey, you're lactose intolerant. For OXTR and empathy gene, we're only gonna look at the top variation because it's the most reliable, it's the most well-researched variation out of these four. And it looks like she's got heterozygous genotype, one sociopath variant and one empath variant. Pretty typical stuff for Eurasians, West Eurasians, which is what she is. For type 1 diabetes, is there this important genotype? There is not this important genotype for type 1 diabetes, so we're gonna skip that. For hemochromatosis, it looks like she is not a carrier for any of the variants for hemochromatosis. Very interesting to see. For Alzheimer's, it looks like she does not have any APOE variants, risk variants for Alzheimer's in APOE, which is very good to see. APOE is by far uh, the most important gene for Alzheimer's score. However, she did score above average for Alzheimer's. So all this together and some more contributed to a slightly above average score. Okay. For multiple sclerosis, it looks like she does not have any risk variants in the HLA, which is really good to see. Once again, these typically come together. So if you have one genotype for HLA, you already know you can sort of impute all the other genotypes in this region as well. In this case, she has four found in the file, and she doesn't have any risk variants in any of the four. So we already know for a fact that she does not have any risk variants for MS in the HLA gene. For cardiovascular disease panel, there's just too much. I don't want to talk about this stuff here. For myopia, we're gonna skip that. Okay, for miscellaneous section, no micropenis. Good to see. Really pleasant to see. Unfortunately, I see a lot of samples with micropenis. Prediction, those are mostly 1240K samples, which does tell you about the type of samples these are, and does not have micropenis here as well. No micropenis variants in either of the two micropenis variations. Impaired muscle performance, likely endurance athlete rather than sprinter. One fat gene variant and FTOs RS9949609, so higher odds of obesity and sleep apnea. CT here, which means she does not have photic sneeze reflex but carries one allele for photic sneeze reflex. GG here, which means no variants for increased pain sensitivity, which is kind of typical. Most people have GG here, aside from, the alternative allele, which I think is A, is most common in South Asians. And for EDAR, she has AA genotype here, which means no shallow-shaped incisors and not East Asian in ancestry. However, in this variation of EDAR, she actually has heterozygous genotype, which is leading to likely not European facial traits. Once again, heterozygous genotype here is rare for Europeans but common for East Asians. So once again, it looks like in this variation of EDAR, she does not have East Asian genotype, but in this variation of EDAR, she does have an East Asian or at least a semi-East Asian genotype. She is not an Asian flusher, okay, and she has GG here, which leads to much larger brain volume, which is very interesting. It's also a very rare genotype to find. So few people have the much larger brain volume genotype here. We're gonna skip. Oh no, we're not gonna skip drug response. Okay, so let's talk about drug response. TT in this variation of Act 1, which leads to lower odds of cannabis-induced psychosis. She can smoke weed without getting psychotic from it. Very important gift to have if you're gonna smoke weed or live in California. Um, okay, for albinism and the typical traits panel, it looks like she is not a carrier for any of the albinism variants, so she's not albino, and she also doesn't carry Melanesian blonde hair variants. Okay, for familiar Mediterranean fever, it looks like she does not have any risk variants for that. For MCHFR, we're gonna skip that. Okay, we did want to discuss testicular cancer. So for testicular cancer, it looks like she's got these two genotypes that increase the risk of testicular cancer. I think in my program I have it print out three most important ones for testicular cancer, three that have the largest impact. So out of those three that have the largest impact, she's got genotypes in two, and in those two she has kind of a risk genotype in both of them. So That's interesting. It looks like indeed she has a high score, high risk. If I made a polygenic risk score for that, she has a high risk for testicular cancer. For leukemia panel, she actually carries the NQ01 allele, which significantly raises the risk of leukemia, which is kind of bad. But all of the other genotypes are good, so maybe it sort of counteracts that. For rare diseases panel, it looks like she's a carrier for an allele of one Gerg's disease. I'm not sure if it's due to genotyping errors or if it's legit, but I think in every sample you analyze, you will find something that is very uncommon because there's just so many things you look for. One, if you look for 200 different things, you're bound to find something that is really uncommon, right? That's kind of the way I view it. So it could be a genotyping error, but it could also be simply uh, a fact that she has it because everybody has something. Everybody has some sort of condition that is uncommon in other people because there's just so many of these conditions. Statistically speaking, if you have like 300 different conditions you look for, you're gonna find something. So yeah, that's pretty much what it is. And I'm pretty sure it's an autosomal recessive disease. So having being a carrier for an allele does not mean you would actually have the does not mean you would actually have the disease. But I think you need two alleles to have the disease here. She's not a carrier for variants for Bloom syndrome. No GSS. She has this genotype, which leads to higher risk of certain autoimmune diseases such as type 1 diabetes and Addison's. Um, okay, for celiac disease, yes. So she scored really high for celiac disease, and for celiac disease, there is definitely a problem. She has this single HLA DQ8 haplotype, and it leads to a very high risk for celiac disease. In fact, only around 1% of Europeans have higher risk than her. So she has very high risk for celiac disease. All right. We're gonna skip allergies. Androgen receptor. It looks like she's got typical high risk of baldness. It's a typical score for Europeans. Pretty much every European is gonna have GG hair, which leads to typical or higher odds of baldness. Compared to that, in East Asia and in Sub-Saharan Africa, East Asians and Sub-Saharan Africans, they have the alternative allele. I think it's the A allele, which leads to a decrease in the risk of baldness and actually sort of protects you from going bald. So she's just a typical European in this regard. Um, she's got AG here, which means possible Reifenstein syndrome. A is the risk allele, which is kind of interesting. That's interesting. Okay. For Crohn's disease, it looks like she's got a lower risk of Crohn's. So for Crohn's disease, she had a high score for that, but uh, out of the three that are important that I had to print on the screen, it looks like she's genotyped for two, and for both of them, she has a very good, very pleasant genotype, a genotype that leads to a decrease in the risk of Crohn's. So for Crohn's, I don't think we have to worry about too much. For Canavan syndrome, it looks like she has zero risk variance for that. Very interesting to see. For HIV and AIDS panel, she has one protective variant in this variation, which leads to 60% reduction in HIV viral load, which is good to see. So, in terms of if she got HIV, it would probably take a little bit longer for her HIV to turn into AIDS than it would for other people who don't have this protective variant. For muscular dystrophy myopathies, it looks like she does not have any risk variants for that, but she has 3 risk variants for adrenoleukodystrophy out of 48 total. Very interesting. Now, if she was a man and she has had 3 risk variants for that in reality, then she would have the illness and she would die before she was like 20 or however long these people live. They generally do not live past 20. But women can actually be carriers, and women can be carriers without getting the disease. In which case, it's either that she is a carrier for this disease, or um, it's that she's a carrier for this disease, or it's that it's a genotyping error and she doesn't actually have these 3 risk variants. So maybe type out in the comments what do you think it is. And for color blindness panel, it looks like she has 0 risk variants for color blindness in OPN1LV, 0 in OPN1MV out of 8, and 1 risk variant in OPN1SV out of 8. So it looks like she actually has 1 risk variant for color blindness as well, which is kind of interesting. But I think color blindness, well, OPN1 SW is located on the 7th chromosome. It's not an X it's not on the X chromosome. So it would actually affect women as well as men. These two are on the X chromosome, so these two wouldn't affect women unless they are homozygous for it. Well, thank you for watching until the end. Leave a like and subscribe if you enjoyed it. You can download this file in 23andMe format from link which is in the description of the video. Leave a like and subscribe if you enjoyed my content. Goodbye.